Now we are getting to some really basic ideas of neuroanatomy of emotion. This is the part 4 of the discussion that we have today, to just have a kind of another understanding about, another level of understanding about what we have with neuroanatomy of emotions. First of all, we know that there are at least many aspects of emotions that we are discussing about in some level available in animals like rat and mice, so we can put them in fear condition or aggression or seeking behavior, so we can put them in different sort of emotional experiences. And there are different pathways in terms of how cognitive systems from frontal cortical areas towards subcortical areas would able to modulate what are the things that are happening here, or how emotions could change the cognitive processing in rat's brain. But in reality, what we have as something like, let me just use this, as prefrontal cortical functions in rat, they are so limited that people right now think about things like anxiety could never be happening in rat. Because anxiety is about uncertainty. And uncertainty is about future. And there is not enough space in prefrontal cortex in rat's brain to be able to represent what are the things that are happening in future. So in reality, we can still have fear in animal models, but having anxiety seems a little bit more complex to be happening in an animal's brain. So people think that anxiety is something like a specific feeling that is related to a human being because of our capacity to be able to put things in perspective in the future and have mental representations about future. So there are some shared pathways with animals, and there are some areas that are not very much shared with animal models. The other thing I'm interested to discuss about is an interesting experience of, I'm not sure how much have you felt being different from the other person. I'm not sure how much have you experienced just seeing a movie with a group of people. Let's say you are in your kind of dining hall or in sitting hall and sitting, kind of seeing a specific video or a movie related to a very famous drama, and you're seeing that together. And then there is a scene that somebody is crying or somebody is getting emotional. And you can see that there are people in your, let's say, group that they can have tears in their eyes, and there are people who are not getting into tears so fast. So how can we be different from each other in terms of having a level of, let's say, empathy or sympathy with others and experiencing the emotions that they have in a movie that you know that it's a movie, so it is not a reality, but you are still kind of feeling the same feeling that the actor, especially if the actor is played in the right way, you can just have the shared feeling and just start to kind of have tears in your eyes. If you want to just, let's say, kind of rate yourself in terms of the level of sympathy with others in movies, in drama movies, and having tears in your eyes, what would be the let's say percentile that you give yourself from 0 to 100% in terms of being responsive to these scenes in the movies? Could you just kind of report that, or do you want to kind of share your experience about that with us? If you are interested, just turn on your video, or if you can just report that, you can just report that here. So we already have Marina is reporting 100%, Sarah 80, 90, 60, 108, okay, 60, 100. So we already have people who just get in tears very fast. Puriya, do you want to kind of share your experience about that?
Yeah, that was a bit of a question for me, that because I had the experience was very variable for me. There were times, I mean, depending on my mood, my current states, I would say 30% or even less. I would say sometimes up to 70, 80-ish. So how is that variation? How should I decide that?
That's interesting. That's interesting. So you feel that you can be in different, let's say, states. So it is really hard for you to kind of rate that inside yourself as a trait. You basically like to rate the state, saying that okay, today I would be in tears probably if I see this kind of a specific, let's say, movie with my family. But if I do it, let's say, yeah, okay, that's interesting. That's interesting. Zainab, what is your experience?
But I agree with Priya, and also wanted to add that due to the social situation we're in, for example, when we're watching a movie with close friends or with a bunch of strangers, for example, the level of inhibition would pretty much very much differ.
I do agree. I do agree. I mean, it depends on where you are located, of course. And of course, there are definitely kind of the role of different, let's say, emotional states on that as well. I'm also interested to have Mikhail's idea for that as well. But if others are interested to share their thoughts as well, that would be interesting. In terms of, have you ever felt that is something hereditary in your family? Feeling that I'm very emotional, my father is emotional in that way as well, but my mom is not. Or my brother is, I'm not. So trying to kind of make something like a pedigree of those who are emotionally responsive or basically sympathetic to scenes in videos, and just saying that, okay, it seems that it's something that is running in my family. My grandfather is something like that. My father is doing the same, and me as well, but not my brother and not my sister and not my, let's say, my mom. So is there any experience in that direction? And I was interested to kind of have Marina, because Marina was reporting that she's 100% to that. So that would be interesting to see that experience as well. Marina, Mikhail, do you want to share your experience, and then Marina would be sharing her experience, or we can start from Marina and come back to you, Mikhail. Mikhail, you are on mute.
Yeah. Well, I think there is kind of an heritability part to it. I can see clear patterns of emotional reaction, and for example, my mother and brother are very reactive, whereas the side of my father's family is totally not. But what I wanted to add to Poria and Zinat was also that it's not only the current situation that I'm in, but for example, if I had a lot of very emotional patients during the day, and my wife forces me to go to a very emotional movie, I will be completely devastated. Whereas when I had a research day and I didn't interact with a lot of distressed people, I can protect myself a lot better emotionally. And that's something I only discovered when I became a psychiatry trainee. That really, after a hard day of work, my capacity to filter emotions goes way down.
Yeah, that is interesting, and yeah, of course, yeah, and something like you get to a sort of an ego depletion level, to be able to exert your top-down regulation to your kind of emotional system. That's interesting. Marina, what do you think about that?
I actually think that I really want to know like why I cry every time, and it's kind of like every time when I see movie, I just like so involved in this, and actually I think only me and my family go so emotional about this. So when you ask this question, I was thinking like, okay, but I really don't have like someone who really joined me in this like crying on movie. So yeah, and I think it's just like the level like how you like involve like you sometimes I just not really like pay attention on the movie, like when you're like sitting at home and at the same time like watching on your cell phones and like check some like social media, and so this time I wouldn't like pay attention and cry, but I think if I just like see the movie and if it's like beautiful pet who dying or something like this, I couldn't insist, and yeah, it's something which I couldn't cope with. So even if it's like I don't think it's really depend on like my mood or like previous what I do like during the day before movie, like before watching it. I think I just totally get involved in like movies, and so that's why I just like real feel all of this like pain and I don't know. Yeah, this is kind of
that's interesting. That is really interesting, and I'm not going to kind of dig too much into that, but there are definitely lots of interesting genetic variations and hereditary variation in terms of how people are responding to that, and then how that sort of trait would predict some other aspects of kind of people's life, and how that would be related to how they basically manage other aspects of their life, how much they like cartoons or not. So there are people who are really getting involved into cartoons, and there are people who are not getting very much into the, let's say, cartoon and animation. So you can see that how these things and how kind of these things would be related to the level of mental imagination that people have, and how that is related to the level of, let's say, reactivity in different parts of the brain. So that's quite an interesting variation you can see. The obvious thing that I'm really interested to see is that just seeing something like 20 people of different family members seeing the same movie and see how they are responding differently in their faces, and how they are, somebody is in tears and somebody is just kind of just not taking that too much seriously. So you can see how people are reacting totally differently. But it's quite an interesting circuitry inside the brain, how we are responding to these emotions. We all know that we are responding to that, but the level of response would be different among different people, and that variation is quite an interesting observation. But to kind of expand what we are discussing about right now in terms of having an understanding about the neural circuitry of what we are discussing about right now, there are attempts in terms of making a sort of one-to-one mapping, in terms of saying that, okay, when we talk about arousal, it is related to amygdala. When we talk about valence, it's about orbitofrontal cortex. When we are happy, we have more engagement of, let's say, dorsal anterior cingulate. When we are sad, when we are in fear, amygdala would get. So people try to just do sort of different one-to-one mapping for being able to have a sort of a neuroanatomy of emotions. But in reality, it is too much complex compared to what we are talking about. First of all, we know that there are different networks involved, and there are some overlaps between different networks. So we have fear, let's say disgust, different sort of other emotions. They might have some specific shared elements, some unique elements to them. So different emotions. It seems that when we talk about what we have in the brain, when we have different emotions involved, we know that these emotions would have different, let's say, patterns, and they have different sort of activations within the subcortical areas. So we call their activations mainly domain specific. So based on the domain of the emotion, there are specific patterns of activation in the subcortical areas. But when we have things related to control, when we control anger or fear or disgust or happiness, whatever we are controlling, it seems that we have a sort of what we call domain general system. So it seems that the system that is controlling anger is the same system that is controlling sadness. And that is the reason that when we have a day full of lots of control in our, let's say, clinical practice, by the end of the day, we feel that our control system is exhausted. So we can easily get into tears, and also we can easily get into rage, which, I mean, they have totally different subcortical activations, but the control system for both of these emotional responses, whether it is just a kind of getting emotional and being in tears, compared to the situation that you are just basically in rage and you are expressing your anger. In both systems, the control would be, it seems that control is doing almost the same sort of activity. So we call that domain general, but for emotions, we call that domain specific. And that is what you can see in terms of when you evaluate activations regarding to happiness, sadness, anger, fear, disgust. There are some differences and shared activations. So for example, when you talk about fear and sadness, there are areas that are shared, but there are areas that are totally different in terms of their activation. So there are shared activation and non-shared activations. But so the pattern is quite specific, but the question is, okay, if I have the pattern, can I say it is happiness, or it is sadness, or it is anger or not? So we know that there is a unique pattern for happiness and sadness and anger. But can I go from the other side, which is called reverse inference? Can I do reverse inference? I mean, having brain activation and say that, okay, this guy is sad, this guy is angry, this guy is fearful, just based on the brain activations. And it seems that we are not very much successful in doing the reverse inferencing so far. I mean, there are definitely hopes for that. People are working on different dimensions of that. But it seems that starting from brain activations and then understanding what emotion is really happening right now, it has not been very much successful with fMRI or EEG data so far. So for example, there are studies that people have done with EEG that, okay, they realize that, okay, when you are happy, your EEG would be like this. And then they show people some picture related to a specific, let's say, products, and see if people have that specific pattern of activation. They feel that, okay, these people are happy about that product, so that means that they would buy that product or not. And most of these power plans are incorrect. So they are just doing a reverse inferencing, which is not correct to do. They can say that the happiness could be represented as this specific activation, but having this specific activation doesn't mean that people or person is happy or not. And that is the complexity that we still have in the field of neuroanatomy of emotion that we need to keep in mind to have a better understanding about that. So we are not still very, very successful in going from the activation to the emotion and saying that, okay, if this is the activation, we can have this emotion. The other thing about kind of having a better understanding about kind of neuroanatomy of emotion is just going back to what we have been discussing about in terms of the fusiform area and parahippocampal gyrus. If you remember, the fusiform area was involved in face or place. Which one? Face or place? Yep. And the parahippocampal was related to place, right? So if we give people sad faces, neutral faces, let's say fearful faces or emotional faces and just giving them a place. We know that there would be higher activation for face compared to place. But the question is, do we have any difference in terms of the emotional representation of the figures in the fusiform area or not? This is the activation that you will see, that of course the fusiform face area would be responsive to faces, but they are more responsive to fearful faces. And then there is a specific kind of really delicate question in terms of, is fusiform area involved in emotional processing of faces or not? What we can see here based on this methodology, we should say yes, it is involved in the emotional processing. But in reality, it's not always the case. Yes, they have more activations for emotional faces, but in reality, the reason that they are getting more activated could be just because of feedback loops that they have from other parts of the brain back to the fusiform area. Because when you are processing a sensory stimuli, you can receive a command from other parts that, okay, it seems that is an important stimuli, please process that more carefully. So more careful assessment of a visual stimuli doesn't mean that you are kind of processing its emotional aspects. You are just zooming in more, evaluating more details about that, paying more attention. So it could just be about having more attention and more precise sensory processing. So this is important for you to make sure that sometimes, okay, when we have a contrast of face over neutral, we can say that fusiform face area get activated. But it doesn't mean always that the fusiform area is processing the emotional aspect. It might be just the secondary level of attention or more precise sensory evaluation that is happening there. So it is important to understand that sometimes areas that are not emotional, very much emotional in the process of the emotions, they can get activated because they are just processing the sensory information in more precise way because of the importance of higher valence of the stimuli. Okay, to just go to a little bit more depth for the emotional processing areas in the brain, we have discussed about, let's say, ventromedial prefrontal cortex, orbitofrontal cortex, dorsolateral prefrontal cortex, anterior cingulate. So these are all the areas that we have discussed about. And as I told you, as you can see here, in this specific brain, you can see here, this is the anterior cingulate cortex. We can label this as something like a paracingulate gyrus, but you can see that, I mean, it is not true that all the patients that we have, they have a paracingulate gyrus here or not. So there are variations for that. So you can see that people could be quite different in terms of the response that they have or the shape that they have in different parts of the brain. But these are the main areas that are involved. Let me just give you more details about what we call as amygdala, which is located here. Simply, most of the studies, I mean, whatever we are talking about amygdala, we are talking about, okay, we have amygdala, one amygdala. But when you talk about amygdala, it is not just one single node. There are some sub areas within amygdala. So we can differentiate amygdala in other parts. And then people have different sizes of amygdala. And sometimes when we want to talk about amygdala, we just need to consider a larger area, which we call extended amygdala. And there could be specific, let's say, basolateral areas, medial areas, center. So there could be some subclusters that sometimes we just put them all together. But in reality, they have different connectivities and they have different interactions and they have different neurocircuitry inside them. So if you are interested to know more about these specific areas, I highly recommend you to start to tease them apart into two other pieces. And this is one of the homework that you are supposed to do. You are supposed to go and see different labels that we have for amygdala within the Brainotome Atlas, and also some other atlases that you might be able to find. And you can even look into different segments of amygdala and see how people try to consider different parts of amygdala. And right now, with the imaging methods that we have, if we consider some specific details, we might be able to differentiate these areas, even within fMRI studies. So I highly recommend you to go into details about that. What you can do, we can also do, this is what we have been doing just kind of a few months ago. We have been just exploring how we can measure the connection between amygdala and medial prefrontal cortex. You can see that how we can define these areas and then find the white matter tracks that are between them. So we realized that there are some white matter tracks, and then we have been exploring that with different sort of kind of, this is just a simple DTI sort of stuff that you can do simply with DTI data, comparing how these parts are related to each other. But it's quite interesting that how these, let's say, even when we talk about basolateral amygdala or central amygdala, how they are related to other parts of the brain and how they are different in terms of their connection to the other pieces of the brain. And you can explore that in Brainotome. So I highly recommend you to go beyond just saying that it is amygdala. You can go beyond that and just have a better understanding about how amygdala are responding. And it's also true for other parts of the brain. So when we talk about the networks that we have been discussing about in terms of orbitofrontal cortex, anterior cingulate cortex, dorsal anterior cingulate cortex, mid cingulate cortex, posterior cingulate cortex, parahippocampal gyro, and then areas that we call ventral anterior insular cortex, which is located here, basically in the same, let's say, loop that we have. These parts are, I mean, you can go to the higher level of depth or resolution if you already understand these kind of terminologies. You can go to the more depth for these specific areas. And those who are right now, when they see this picture, now they can easily read this abbreviation. I really congratulate them, because this is what they have acquired during the last couple of, let's say, 10 sessions of working with neuroanatomy and how these parts of the brain are functioning. So it's great that you already have developed this level of a skill to be able to read them. But you can go to the more depth. For example, for insular cortex, as you can see here, we can divide that into ventral anterior insular cortex, dorsal anterior insular cortex, and what we call posterior insular cortex. And as you can see here, it is quite easy to say that, okay, insular cortex is involved in interoception, but it is more than just labeling one specific part of the brain as with a specific cognitive function. As you can see here, even within the insular cortex, these parts in the, let's say, dorsal and posterior part of insula, they are more involved in interoception. There are some areas that are mainly involved in the sensory motor integration, and there are areas that are more towards the emotional processing and attentive emotional processing that you have this part. And even when we talk about their cytoarchitecture, we know that they have different cytoarchitecture in terms of having granular neurons, having disgranular neurons, and having agranular neurons, and how these different, let's say, structures would contribute to a complex concept that we call interoception. So things could get into the far more details when we talk about these parts of the brain, and you can eventually move forward and having a better understanding. And I can show you some of the slides that we have recently developed in terms of there are some of the activations and connections that we have are just with ventral anterior insular cortex and not any other part of the brain. So that is quite impressive that some of these parts are connected to some others and some others are not. So there are lots of really interesting interactions. And now I can add this part to your homework in terms of recommending you to go into the Brainotome areas and differentiate different parts of insular cortex. So I hope that in this session of neuroanatomy about emotion, now you can get to a level to be able to go to Brainotome Atlas and explore medial and lateral amygdala, and also 6 different parts of insular cortex that you have in brainotome, and realizing that when we talk about insular cortex, this is not just one single cortex, it has different parts and it has different labels and names inside. And this is quite interesting experience of being able to get to that level of resolution in human brain, and that basically gives you a higher level of understanding about how these parts of the brain are working. Okay, good. That is the end of this section.